Hi, welcome to solveandgo.com. This is the next in a series of videos giving solutions to the final exam for MAT135 in 2010. This is question number 19. This is a question about the derivative of inverse of a function. So we have f of x is 3 to the negative x plus 9 to the negative x for all x. And then we're told that g of x is the inverse to f. And then the idea is to find g prime at 2. Okay, so we need the derivative of the inverse of x. We need the derivative of the inverse of f. So, knowing the formula for the derivative of the inverse, you take the derivative of f and plug in the inverse function at the given point. Okay, so that's the formula. So, just translating, they call g of x f prime. So g prime is 1 over f prime at g of x. And so then when we plug in 2, we get g prime of 2 equals 1 over f prime at g of 2. So we have the function f, we can get f prime. So now we need g of 2. We don't have g explicitly, but we know it's the inverse of f. So let's copy down this formula here. And now we're going to try to find what g of 2 should be. So remember how inverse functions work. So let's call y equals f of x is 3 to the negative x plus 9 to the negative x. Then to get the inverse, we switch the variables x and y. So we get x equals 3 to the negative y plus 9 to the negative y. And we want to plug 2 in for the inverse. So 2 is going in for x. So the goal here, let me just write this, is to find g of 2, which by definition equals the f inverse of 2. Okay, so we're finding the inverse of this function. So we switch the variables, and for x we plug in 2. So we get that f inverse of 2 is the value y such that 2 equals 3 to the negative y plus 9 to the negative y. Okay, so just take a minute to think about that. And we're going to solve for y. So how do we solve for y? Well, we see we have 3 to some power and then 9 to some power, and 9 is a power of 3. So we're going to rewrite this as 2 equals 3 to the negative y plus 3 to the negative y squared. Okay, so using our exponent rules, we can do this, but just as an aside here, 9 to the negative y is 3 squared to the negative y, which is 3 to the negative y times 2, because here we're just multiplying, and we can multiply in any order. Okay, so let me erase this. Now we want to set everything equal to 0. So we get 3 to the negative y squared plus 3 to the negative y minus 2 equals 0, which looks like a quadratic if we let, say, z equal 3 to the negative y. We get z squared plus z minus 2 is 0. And we can solve this here. This factors as, let me erase what's on the bottom here, I give myself some room. This factors as z plus 2 times z minus 1 equals 0, and the two possible roots are z equals negative 2 or z equals 1. Z is 3 to the negative y, so we get 3 to the negative y is negative 2, or 3 to the negative y is 1. The exponent of a positive number can't be negative, so that means 3 to the negative y can't be negative 2, which means we know the solution here. Okay, so finally, 3 to the negative y equals 1 means that exponent must be 0, so negative y must be 0, and hence y itself must be 0. Okay, and recall from before how we set this up. Y is equal to f inverse of 2, which is g of 2. Okay, so g of 2 is 0. Alright, now we just plug into our formula. We know g prime at 2, which ended up being the derivative of f at 2, equals 1 over f prime of g of 2, which is 1 over f prime at 0. So we're left to calculate f prime at 0. Remember, f of x is 3 to the negative x plus 9 to the negative x. So f prime, again, let me write this up here. F prime is, well, we're going to use the derivative of an exponential. Okay, again, a formula you'll need to remember. So we get 3 to the negative x times ln of 3. And then because we have negative x in the exponent, we need to multiply by its derivative, which is negative 1. And then the same thing for 9. So we get plus 9 to the negative x ln 9 times negative 1. And we need this at 0, so let's just go ahead and plug in 0 straight away. 3 to the 0 times ln of 3 times negative 1 plus 9 to the power of 0 ln of 9 to the times negative 1, which equals negative ln of 3 plus ln of 9, which equals ln of 9 is negative ln of 3 plus ln 9 is 3 squared. So we'd just like to simplify this. If you have the answers in front of you, you'll see that a lot of the answers are in terms of ln of 3. So we're going to use our, as we saw, the answer we're looking for, g prime at 2. Okay, so we did this a few minutes ago, equals 1 over f prime at 0, which we just found is negative 3 ln 3. So we get negative 1 over 3 ln 3. And that's the solution and answer to question number 19.